Question 13. So we're being asked to find an equation of the line, so we're going to be needing to use the formula y minus 1 equals mx minus 1, and to use this we require 1 point on the line x1 y1. Well, we know 2 points on the line, so I'm going to choose to use the simpler one, 1 2, so my x1 will be 1 and my y1 will be 2. But before I can utilise the formula, I need to work out the gradient now. Now if you know 2 points, the easiest way to work out a gradient is just to do a quick sketch and then do the y step over the x step. So here's my sketch, minus 3 plus 5 and 1 2, and then drop down a vertical and pop in a horizontal to create a triangle. Now our x values are going from minus 3 to plus 1, so that's the length of 4, and our y values are going from 2 to 5, so that's the height of 3. Our gradient equals our y step divided by our x step, which is 3 divided by 4, but because the line's going downwards, that's minus 3 over 4, so our gradient is minus 3/4. So I can now use the formula. Now, we need to give our answers in integer format, so we don't really want to be multiplying out by fractions and what have you. So I'm going to choose at this early stage to undo this dividing by 4 by multiplying both sides by 4. Now on the left, that's just going to be 4 times y and 4 times minus 2, so 4y minus 8. And on the right, that just undoes the dividing by 4, but I've still got the minus 3. So I've basically got a claw here where it's minus 3 times x and minus 3 times minus 1. So that's minus 3x and plus 3. So that's how I get to this. Now I'm being asked to give my answer in the format of x's plus y's equals a constant. So I'm adding 3x to both sides and adding 8, so I've got x's plus y's equals a constant. 3x plus 4y equals 11. Now for part B, I'm being asked to show that one line is perpendicular to another. So whenever you're asked to show that lines are parallel or perpendicular, focus in on the gradients. Now if you're being asked for them to be parallel, it's easy. You've just got to prove that the gradients are the same. But here, where you're being asked to show that they're perpendicular, you need to show that when you multiply the two gradients together, that you get minus 1. So we need to go and work out both the gradients, multiply them together, get minus 1, and say therefore they're perpendicular. So here goes. For line L1, it's dead easy, because this is already in y equals mx plus c format. Our gradient is m, it is 3. Now for L2, we've got to rearrange it to get it into y equals mx plus c format. We only want the y's on the left hand side, so we take away 2x from both sides. So at that point we've got 6y equals minus 2x plus 1. But we don't want 6y, we want y, so we divide through by 6. So y equals minus 2 over 6x plus a sixth. Simplifying the gradient, we get y equals minus a third x plus sixth. So the gradient of L2 is minus a third. So we then go and multiply the two gradients together. 3 times minus a third is indeed minus 1, which is what we were hoping. So we can then conclude that L1 is perpendicular to L2.